Now, what makes a good phenomena? The first thing that makes a good phenomena is it should spark curiosity and it should spark wonder. So here's an example of a phenomena that I use in class. If you write on a glazed plate with just a regular dry erase marker, you let it dry a little bit, and then you pour some water on it, the letters are going to start to float up. First time kids see this, they're like, wow, that's amazing. Why is that occurring? Once they start to say that, you know that you have them. Once you show them something, they want to understand what's going on, now you've got a pretty good phenomena. It's important, however, that your phenomena that you choose addresses a standard. I could spend weeks on this as the kids investigate different parts of it, but if it's not tied to a specific phenomena, I'm wasting the student's time. This case, it's tied to this physical science standard on intermolecular forces and bulk structure, so I'm good to go. You also want to make sure that it can be investigated. What's great about this phenomena is the kids could do their own experiments in class and kind of test those ideas of what they think is causing this behavior. Now, you also want to know that all phenomena don't have to be phenomenal. What does that mean? If kids can investigate and we put them in the position of a scientist, they're going to engage. So I was planning a lesson with a teacher, and it was just essentially on Punnett squares. And we wanted to figure out what's the phenomena going to be, and we just gave them the data from Gregor Mendel. We just gave the data that he had and put them in the position of a scientist, and they totally engaged. I've done this with the finches of the Galapagos as well. Just give them the data, put them in the position of the scientist, and they're going to have fun.
Okay, so did you hear what Paul said about good phenomena? Well, he said they spark curiosity and wonder. They address the standards, which is critically important. They can be investigated by the students so they can gain their scientific knowledge to understand the phenomena better. And they're not always phenomenal. Sometimes just putting information in front of the kids, as long as they're engaged, that could be a key phenomenon utilized in class as well. Okay, so there are multiple kinds of phenomena. There's the anchoring phenomena, the investigative, and the related phenomena. But what we're going to do is focus on that anchoring phenomena. That's the one that can last like a whole unit. For the example we've been going through, the collapsed tanker, that was serving as an anchoring phenomena for that teacher. It was covering multiple standards and it could be referred to over the course of probably weeks. Now that would be our goal. We're going to have to look at our standards and get to know them deeply and to see, is there a way we can bundle them together to then maybe package a phenomena to do this. Now, it's really hard to find and figure out an anchoring phenomena, and we truly don't know if it is an anchoring phenomena until we get it in front of students. So our goal in the next several pages is for us to collaborate and brainstorm together some ideas about anchoring phenomena for our first quarter. So this means it's time to put on our teacher hat. What was up with that guy during the video? He's weird.